Hello everybody, how are you doing? This is William Paul Liggett from Junk Text, and today you are going to be learning about Java programming. Okay, so this is one of the first courses in this series that we're going to be going through. So from this aspect, I assume you pretty much have no programming experience whatsoever. Okay, now it's okay if you already do have a bit of background with computer programming. That's fine. There might be some things that as you go through, you'll understand a little more subtleties of how Java and its personality is with programming. It's a really powerful language. It's a very in-demand language, and I think you're going to get a lot out of understanding how to do a lot of things, which you can use, by the way, in other languages. That's one of the great things about being a computer programmer is, yes, it can be hard to keep up with certain things, but guess what? Actually, a lot of things, there's a lot of similarities that if you just understand the basics, you can pretty much get by on your own. You can figure out how to do things in other languages too. Okay, so with that in mind, we're going to be covering in this video today a number of different topics. Now, this is going to be a very interactive portion. I hope you've already seen the aspect of installing what's referred to as an IDE, an integrated development environment, so that I actually do want you to follow along. I want you to practice programming as well. Okay, so that's the thing. You can't learn how to program unless you actually just try to program. All right. So the basic aspects that we're going to be going over is, well, what is Java? Other things such as JavaScript is not Java. That's a good catch-all thing to see if you know what you're talking about. That's a good interview question. They're just different. Okay, I'll just put it like that. Other things. You're going to understand the difference between data versus information. And yes, there is a difference. Okay, a lot of people mess this up, but no, they're different. Also, practical things like actually coding. I'm a big fan of what's referred to as comments. Okay, so comment in your code. It's going to help you out in so many regards. Any professional programmers out there that might be watching this, comment your code. You kill me. All right. All right. Moving on. You're actually going to do the classic starting point of computer programming, which is your hello world program. All right. It's just a common thing to say, hello world. All right, in code. And then with that, you're also going to understand more than that. We're going to go into what's referred to as escape characters, such as a very common, it's a \n. And to understand the subtleties of what that means in different regards. In later aspects, you will have a more fine-tuned understanding where this comes into play, but for right now, it'll be more the basics. And then we're going to be also getting into the aspect of variables, okay? That term, if you have been part of any sort of math, like algebra math class, you might have, 2x plus 3 equals 8 or something like that. Well, the x would be a variable. In this case, computer programming has a very similar thing, basically, but it's kind of, it's kind of meant for other things sometimes. And you're going to understand how to do this with Java, okay? So, yeah, we're going to be covering lots of ground. And I say let's get started. Wait a minute. Now, if you don't know me, all right, we got to start. We got to get off on the right foot. So let's liven up the mood a bit. All right, here's a joke for you. You ready? You ready? What does a nosy pepper do? Gets jalapeno business. Yes, that's good. All right, let's get into it. All right, so before I go into the rest of the material on the introductory to basically Java programming that we're about to go into, I just want to give a quick summary of my bio, just so you have an idea who's teaching you this information. So as I mentioned, my name is William Paul Liggett. I am a polyglot programmer, which is just a word, you don't really hear that as much, but it just means that I deal with different programming languages like Java, Python, PHP, HTML5, and JavaScript, and so forth. I deal with different databases. I also have another lecture series on database technology. Currently, as I'm filming this, I currently teach as an assistant professor at Northern Virginia Community College as a software engineering instructor, and I do the same thing at a non-profit college basically institution called Year Up. And then, you know, there's my company, Junk Text. I've done a lot of different things in the past. I've been a programmer for the defense and intel world. I was an IT project manager at the Pentagon for about 4.5 years, and I was also a sysadmin at the Pentagon and also the Defense Intelligence Agency. And prior to that, I was a Marine. Yes. So what that means is you don't mess with me, all right? Just joking. And my background, I have my my master's and bachelor's from George Washington University, and those are some of my certs: Security Plus, Network Plus, A Plus. I also have my AWS Cloud Practitioner. So anyways, let's get into it. Okay, so what is Java? All right. Now, this is a very popular programming language, okay? One of the things with that, it's referred to as a high-level programming language, which means you don't have to worry about certain aspects that lower-level languages you'd have to worry about a lot. One of the key things, for instance, when you're a Java programmer, is you don't have to worry about managing how you interact with computer memory, the computer RAM, as much, which is really, that's actually a really sensitive area when you're programming, because that's where a lot of vulnerabilities can happen in applications that were written in something like C or C++. There's nothing wrong with C and C++. They have a lot more power, honestly. It's just that they can also be a little more dangerous if you don't know what you're doing, kind of a situation. So with Java, they take an approach where it's kind of almost like if you're familiar with, say, VirtualBox or VMware. It basically takes that kind of a aspect. If you see my last bullet point there, that it runs on what's recalled to as a virtual machine. So the JVM, that's literally stands for the Java Virtual Machine. So it's kind of like VirtualBox, say if you're running Windows and you virtualize Linux inside of Windows. If you don't know what I'm talking about, don't stress as much. It's kind of the same idea, except that we're not doing a full operating system. That instead it's like this little isolated kind of, you wouldn't even really know about it, but it's like this little Java world. That's where your code runs in this. That's where your code is running, is in this Java virtual machine. Okay, and so the reason why that is useful in this regard, and why it's a higher level language, is the environment is what's referred to as cross-platform, meaning that, for instance, it could run on Linux, or you could say, you know, GNU/Linux. It's the same thing. So you got Linux. It could run on Windows, Mac systems, and so forth. Now, how this works generally is that you write your program once, and it should generally run on all these other platforms. And that's because as long as your code works in Java and it runs in a JVM, for the most part, unless you're doing something very particular, you can pretty much get your code to run on these different platforms. Okay, so the lower level JVM thing you don't even care about necessarily. That's actually managed by a company called Oracle. So they actually address that cross-platform type thing. So then for you as the Java programmer, that's when you're just creating your application code, like you want to create a game or whatever. Like it could be, it could be web development in Java programming and so forth. that's basically the gist. I'm not going to get too deep onto the ins and outs of how this technology all works. The main idea is it's a little more abstract. Like, you don't have to worry about handling RAM, like how your program runs in the computer memory, like what you would have to do as a C or a C++ programmer. So in some senses, it can actually be easier to do things. But that the easier aspect doesn't mean it's like a weaker language. It's actually very powerful because it's been around for a long time, and there's a lot of organizations, companies that have a lot of Java code built in. Like, there's a lot of web enterprise type stuff. There's full games. For instance, I play this game called Project Zomboid. That's a cool cross-platform game that you're trying to survive this zombie apocalypse. It's fun, all right? Anyways, it was created in Java, all right? But there's a bunch of other things in this regard. Let's move on. Don't worry about the technicalities of all this stuff here. This I'm just kind of clarifying for those with more of a technical mindset. You can understand what I'm saying here. The only thing I will say is we're gonna We're gonna be dealing with what's referred to as source code. So the source code is actually the Java code that we write. Okay, and that's the file that eventually gets compiled, or it's translated, okay, into basically ones and zeros. And so we are dealing with, and this is more like computer code, English looking stuff. So it'll be a .java file, and then when you compile it, you go through this process, you'll end up with what Java likes to call .class files. Okay, but you don't have to stress about understanding everything at this point. Okay. One of the things before I go further, this is a big no-no. Do not mess this idea up. Do not claim you watch my video and then you're still messing this idea up. Now, I'm not going to go into JavaScript, but one of the things to be clear is, if you've ever heard of JavaScript, JavaScript is not Java. All right. It's long story short, it was actually when JavaScript was coming about in the early 90s, they wanted to compete and basically convince people to use their language. It was a web development for browsers to do things, and they wanted to basically kind of trick people into using their technology, which honestly it was a good marketing technique because it worked over time. And yeah, but the main thing is JavaScript is not Java. If you're looking at the code, if you look at by chance JavaScript code and then Java code, and you just kind of look at it generally, the syntax, or like what the code looks kind of similar, but they're totally different like environments. They're not even like of how things work when you're coming up with your program. They're just totally different. Just trust me on this, okay? One of the things on that though, now historically, or not historically, but like where we are today is that JavaScript, where you're going to see that a lot, they have basically dominated this front-end web development technology, which means like when you go to a website in your browser, it might be doing more advanced things than just like a static web page thing. JavaScript might be involved to make those features work. Okay, so Java is not used for that. Okay, it's actually used. It can be used for what's referred to as back-end, like server programming, like server code, such as like when you connect to a server and you log in to an account. Well, that feature of it, like checking some database server or something like that, and there's like security, you're throwing your password and stuff like that. There's a back-end kind of hidden process on the server side that you can't just directly see the code of how that works. Now, Java could be used for that area. It's not the only type of programming language used for back-end web development, but it is popular in that regard. JavaScript can also be used, like what I'm saying here, to do that as well. There's this really popular project called Node.js. So it can, basically you can do back-end programming. as well, but you're just fully using JavaScript, not Java at that stage, because a .js is JavaScript. You can also, with JavaScript, now again, this is not the language that we're covering, but I'm just letting you know, you actually can do lots of things with JavaScript, such as you can actually create full mobile apps and things like that. A popular project to do this is called PhoneGap. There's also, which is based off of the Apache Cordova project, and they use, they basically come together. It's like a look when you create your app in this thing. It basically makes it like a offline website in a sense. It uses HTML5, CSS3, and JavaScript, and maybe some other things going on. And it runs on, say, your Android or iOS, your Apple phone, or something like that. But you wouldn't, and it doesn't have to be connected to the internet. It's like a little localized website app thing. All right. So that it could be used for that. Now, again, we're not covering JavaScript, just to be clear. I just want to let you know what is what, where things might be used, and such. Now, for Android, okay, or not Android, for Java, I'll get to the Android thing in just a moment, that Java is definitely, you still see it with, say, desktop programs or games, like I was mentioning, such as Project Zomboid. It's a fun zombie apocalypse game. And so that's written in Java. You can do other things like create a calculator program or whatever that can run on different environments. For instance, on my website, junktext.com, you can see a simple blackjack kind of gambling program. It's nothing too intense. It's more, I kind of built it so people could kind of study how this works, and I was putting together the technologies like unit testing and such, and all the code is out there. You can see how it works, and I have instructions how to run it and such. So the cool thing there is that, like, you have your code, you have what's referred to as one code base. Like, you write all of your program code in Java, and then it can work in Linux, Windows, and Mac, and so forth. Okay, so that's also where you can use Java, the Java language. Pardon me, I just got to get me some more coffee. Coffee, which is a slang term of that, is called Java. It's kind of why it has a name. A lot of programmers need some way to stay awake. My drug of choice is coffee. Right? So the thing with, a lot of you may not know this, but basically like 99% of every Android application you've ever used, like if you downloaded an app from the Google Play Store, or there's another app store called like F-Droid, that the code is all written in Java. Okay, so all those Android apps are written in Java. Now, I say like 99% because look, you could use JavaScript like PhoneGap. It's not quite as popular. It's doable, and there's other things, like for instance, you could even use like Python or other types of, there's C# from Microsoft that you can create apps for Android, and other things like that. But for the most part, Java is just dominating the Android apps because how you do standard Android, like when you create an Android program, as if you're using the Google Studio, the SDK, to create an Android app, it's Java code is what you're doing. Okay. All right, let's move on. One of the things that could kind of like maybe explain this in a different way of what the difference is between JavaScript and Java, because you do not mix this up. You will get asked this in a job interview. They like to kind of see who's paying attention. All right. That I'm saying, like, JavaScript is a very abstract, it's a very kind of loosey-goosey language. It lets things go. There's ways to make it a little more strict. There's a thing you can make it really strict, but the default way of how JavaScript works is you could say something like if you were speaking French. Now, I don't know how to speak French, so I'm probably not going to pronounce this as correctly as it could, but like a slang kind of thing, like if you said like "ça va," which is spelled like this in French, okay, you'd say this "ça va." A rough translation to English is basically saying like, "Oh, how are you?"
right? And people would like kind of chatter like that. Java, though, is very formal. It's like, there are rules. This is how you do it. You do not talk to me in some slang halfway thing. We're going to talk proper English, okay? I'm not being mean to Java. I'm just saying that it's very, like, that's its personality, okay? You have to just understand it likes things to be, like, really kind of put together properly, okay? Like, so, in this case, you couldn't do this save all kind of situation, like, hey, what's up? Or something like that in Java. It's more of like you want to be very accurate with all the little grammar rules or whatever. So in this case, it's kind of like you would be required to be like, you'd have to say like, oh, hello, Mr. Liggett, how are you today? And if you don't do this whole proper kind of put together thing, like Java will just like yell at you, give you an error message, it's just going to crash. Like, I'm not saying you can't have Java printing out this, what's referred to as a string, like text. Like we could print this out. I'm just saying, like, JavaScript, there's not too many rules. Like, it's like, rules? Who needs rules? And Java's like, we need rules. I want all these rules, right? So that's basically the deal between these two things. Now, I actually like both languages. I just understand them. And, you know, it's not like you have to hate one or the other language. Those gets into debate wars of which one's better or whatever. They both are great. So I'm going to move on though. Okay, so who even uses Java? All right, well, a lot of people. And one of the things that you know, even in your career, what you want to do to kind of, you know, forecast what languages and technologies you might want to study, it's kind of guesswork sometimes. All right, hold on one sec. Need me more coffee. All right, so this is this really popular ranking system. It's called the, I might pronounce it wrong, but I call it the TIOBE Index. Now, if you've never heard of the TIOBE Index, they get quoted often in like news articles, like for technology things, like you might see in Wired or something like that. And currently, Java, and it has been for a long time, it's ranked as like the #1 language, okay? And let me show you what I'm talking about. I'm going to show you this TIOBE Index. So like if you go to, oh, there we go. Then you go to here. I just pulled up, like you could just search. I'm using DuckDuckGo, which is like Google, but it doesn't track you. Anyways, if I typed in TIOBE Index up here, all right, that the first thing that showed up was this TIOBE Index. So I've already clicked on that and I brought it up over here. Now this is, I'm pulling up this website in March of 2020, okay? So what the TIOBE Index does is every month they basically track what is, I'm gonna zoom in maybe, yeah, that they kind of summarize an event every month or something like that. So they have this language that it's not as popular anymore. It's not that it's a bad language. It's called Delphi, and they're saying, oh, Delphi is about to fall out of basically their top 20 ranking. They rank a lot of languages. I'll show you a summary of that in a moment. But so this kind of summary is kind of interesting to look at. But what a lot of people, you know, if you want to forecast your own future, of like read the tea leaves to figure out what languages to study, okay? Like maybe you look at this TOB Index and you're like, oh, should I learn Java or Delphi? And if you're looking at it from a selfish reason of like, hey, well, I want to go find a job later, I'm assuming Delphi may not be quite as popular anymore because it's like getting kicked out of their top 20 list. So this is what this TIOBE Index can help you kind of do, all right? It's the thing though is they're even explaining how this works, and you can read their methodology. They explain it more into details. One of the things, the TIOBE Index, it's not like a scientific methodology for ranking programming languages. It's what it's doing is trying, as I say, it's like the indicator of the popularity of programming languages. So it checks like such as like what are people searching for on different search engines. So like Google, Bing, Yahoo, and such. Does it have a Wikipedia page? Like, are there, you know, stuff like that. Okay, so it's like how much chatter is on the internet of people talking about, say, Delphi. Well, apparently that's not as popular anymore. There's not as many people talking about Delphi, so it's almost out of the ranking list. All right, but if I'm going to scroll down here, look at this thing. I'll break this down a bit. Here is the Java programming language, okay, and it is number 1 currently, March 2020. Then look at this. This is also showing you last year. So last year, March 2019, it was also number 1, right? And so here's Java, and it says the ratings is 17%, almost 18%. What this is like, it's like if you had like a pie chart or like a bar graph, that this is 17% or almost 18% out of 100% of how popular, how many people are like talking about Java, comparatively speaking to what they're seeing on the internet. So that's pretty big, actually. It's a lot of chatter, a lot of activity still with this Java programming language. And what this is also saying is, like, from last year, Java's actually gone up almost 3% of this thing, which is actually pretty significant. Because when you look at some of these other languages, like another really popular language, this is a systems level programming language called C. That's going to be popular still for a while. It's a little bit, it's almost as popular, I guess. It doesn't mean it's more. It doesn't mean that Java is more important. Again, the TOB Index is just kind of highlighting which is getting the most talk about on the internet at the time. Okay. Python is becoming more popular. Python and Java are kind of like direct competitors in their sort of sense of how they work. Then there's like C++. So there's a bunch of languages here. So that's the thing. It's like, if you want to forecast what technologies to study, this can potentially be an indicator to look at. All right. Now let me scroll down. They also have, so here's their top 20. So Delphi is down here, which is only 0.71% of the basically pie chart or bar graph, which is really small now. They're not even a percent. Okay. I'm going to scroll down. Here's actually a history timeline. We're looking from like 2002. This blue line here, this is Java. Look how like high Java has been up on this chart just over time. I'm looking at the blue line here. Okay, so since say 2001, it was super high, like above 25%, and then over here it's at like, for 2020 it's almost 18%. So it hasn't really gone down all that much. It's still like dominating. Whereas, say, I don't know, C++ is still really popular. You can't really go wrong with C++. But I guess chatter-wise, it's been going down trend-wise. There's a little more competition in that space to some degree. So this gives you a longer running history, so you can, kind of gauge what's out there as well. Another thing, what I did for you when I was creating this video is I'm going to take this information that they have here. I've already created I'm summarizing it in a different way and I made a little chart and so forth. So let me show you that. I'm using, this is like Microsoft Excel, but I'm always passionate advocate for open source software, which is also called free software, because you get a lot of freedoms and so forth. Anyways, I'm using what's referred to as LibreOffice, okay, and I'm using their calc program, so it's like Excel. And what I did is I copy and pasted, I'm putting the source here, the content from the TIOBE Index, and I just put it in and I stripped out, I just kind of slimmed it down a bit. It's the same stuff, I just kind of reduced some of the details. So here's Java, which is at like that almost 18% thing. It's gone up from last year, 2.9% and such. And so the visual kind of thing you can look at is the green is like pretty high up in the ranking. Yellow, it's like it's not bad actually. Like PHP, it's like you can't go wrong with PHP either. It's apparently only got like 2% of the internet chatter, but a lot, like, I don't know, 20 some percent or more of websites run PHP. So it's not like a worthless technology, okay? But anyways, so then you have Delphi that's way down here. You know, it's kind of in the red. It's low ranking, so that's why that you have this red, yellow, green thing. That's what I'm doing here. I did the same thing with the changes, so you can see if, like, you know, C++ apparently it's going down a little bit more from last year. And you know, it's visualbasic.net and such. It's still pretty high up and such. Anyway, you can get some more, you can study these numbers more on your own if you want. But with Java, say this nearly 18%, look at this bar chart that I've created, and you get a more visual way to see, like, Java is just like, boom, just dominates everything, and then everything else adds up basically up to around, I don't know if it's 100% completely, I had to check the numbers, because I think it's also excluding, like if we look at, let me just go back to maybe the TOB Index, they track more than 20 languages, because if you go down, so here's other programming language, so it actually goes up to, on this thing, tracking all the way up to the 50th most popular language, and then they're like, and then the next 50 programming languages, a bunch of stuff, blah 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 blah. All right, so they're like, we're not even bother ranking this. So that's where all these other little percentages are here. So I don't think, you know, these should not add up to 100%, but it's still, like, for the most part, it's like, I don't know what the total is here, but it's probably pretty close to 100%. So that's the kind of visual snapshot of what I'm talking about to help you understand, like, the popularity of the Java programming language. So that's why, you know, I just wanted to explain the popularity, not just me saying, oh, it's a very popular language. Like, yeah, okay, sure, William, blah blah blah. So let's continue on with the slides that I have prepared. Okay. So like I said, basically every Android app is created in Java. You could use other languages, but for the most part, it's Java. That's why it's super popular. That's part of the reason why Java is so popular. And, you know, a lot of people use Java worldwide. Okay, it's just popular. Moving on. One of the things when you're trying to be a computer programmer, you need to understand, do not mess these terms up, all right? There actually is a difference. You might like have used this, and a lot of people use this interchangeably, like, oh, you got the computer data on this, I really need to see blah 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 blah, or hey, I sent you can you pull up the computer information or something like that. A lot of non-technical people, non-programmers, they just kind of flip-flop these terms to basically mean the same thing. They actually are different though, and I'm going to explain that difference, okay? As a programmer, you do not want to mess this up, because if you go somewhere and you're working somewhere and you use these terms kind of interchangeable, they're going to look at you funny, like, do you know what you're talking about, right? So that's the thing. What do you think the difference is between data and information? I'm giving you a second. What do you know, I just want your own thoughts. What do you think the difference is? Well, the main difference is data is input. Okay, I'll explain input in a moment. Data is input and information is output. So, for instance, if you can see this, data is input, right? Well, one of the things, look at me moving my mouse. I'm moving my mouse over here. Here, I have my finger on my touchpad on my laptop here that I'm creating this video on, and I'm moving the mouse left and right, back and forth. So what I'm doing, the data that I'm providing to the computer is me literally with my finger, I'm touching my touchpad, and I'm moving my finger left and right, up, down, and stuff like that. And the information that I expect to happen, like well, obviously this is what you do, but no, there's actually like a computer program to make all this work, right? Well, the information, the output that I want to see is my mouse moving around, okay? Like, it shouldn't do anything else. Like, that is what I want it to do. So again, the input is me literally providing, physically me moving my finger around, okay, and the information, the output is like, well, move this little mouse cursor icon thing around on the screen. That's what it should do. Like, imagine if I like did this, like, oh, left, right, left, right, left, right, or something like that, and then the computer just shut down. Like, what kind of, that'd be terrible, right? Like, be like, what just happened? This is a terrible program. That is not the output that we expect, okay? So that's the thing. When you're a programmer, you got to think like input is like the data provided to something, okay? It's a more raw level thing that you're dealing with, and then the information is the output. Another way that you, by chance, might be familiar, like if you boot up your computer like a traditional desktop or a laptop computer, that if you look really closely, like say if you're running Microsoft Windows or something like that, the computer does not like instantly turn on to Microsoft Windows. You don't see the graphic for the Windows logo to pop on there immediately. Instead, what you should see at least a little bit is more like kind of this old looking screen, and it's like kind of a bunch of black and white text or something. Maybe there's like some random other logo or something like that. You might even see this term called the BIOS, okay, BIOS. There's a newer term called UEFI, all right, and that is, but the UEFI is a BIOS, okay, and the BIOS, just to touch on it, is what your computer, when you turn the power on your computer, the very first thing that it does is actually enter the BIOS, okay? The UEFI is a BIOS, it's a more modern BIOS, but I like the term BIOS because it's easier to understand. That BIOS, B-I-O-S, stands for the basic input and output system, okay? Input, it's like the computer's checking like, oh, do I have a keyboard? Do I have a mouse thing? Do I have a hard drive? It doesn't know this immediately. It's doing a self-check. It's doing a basic input check, like a basic input, like what are my input capabilities? And then it's like, output. What do I have for output? Well, I have a computer monitor, great, so I can show stuff on the screen. There might be, your sound, your speakers. Oh, okay, I can push out some sounds and stuff. Those are its output capabilities. So once it knows basically the hardware that it has, it then loads up Windows and it informs the environment, like it tells Windows like, oh, this is all the stuff you got, blah, blah, blah. All right. So that's the deal with this BIOS thing. That's another way of thinking this. Another thing is you might see websites like, for instance, like github.io or something like that. Some programming projects have like github.io as their website. What they're doing is the .io is input and output. And actually, it's not technically what it is. It's actually a country. It's like the I don't know. It's like the Indian Ocean Territory, or I don't know, some country. I forget exactly offhand. But in the tech world, they like to use this .io for a lot of like tech projects and stuff. And what they're saying is it's literally input and output. It's like a cool little hip technical way of saying that. All right, and that's what I'm saying. Like, technical people do care that there is a difference between data versus information. So with that in mind, let me show you another example of this. Look at this. Say we just have, you're going to see this guy's, I use this example Bob a lot. All right, it's just because it's short. It's just an easy name to say. My name is not Bob. All right. That say we just have Bob as computer data, and you're like, okay, what is that? Why do I care about Bob? What is Bob? So that here, now if we put it in a computer program and say we're using that data Bob for a reason, and we're like, oh, well, the current user logged on is Bob. So that's the thing. When humans, we don't really care as much about the data. Like, it's important, I guess, but ultimately when we're using a computer program and stuff like that, we want the we want the information. Okay, we want to know, like, well, what's the deal? I don't like make it usable. All right, so that's the difference with data and information. All right, you have something, and then you're making sense of it. You're making a purpose out of this data. Okay, let me give you another example. Say we have two pieces of data, okay? We have Bob and 20. What do you think I'm going to do with these two pieces of data? Give me a sec. Oh, were you guessing that might be how old Bob is? Well, that's the thing. You can't just guess by just looking at data what the information will be. Because in this case, we have Bob and 20, but we're not putting it in context. And so in this thing, say the program was dealing with, say, some social media thing, like some Twitter thing or something like that, that it's like, oh, Bob has 20 friends. Okay, so you see the kind of more point to this. It depends on what you're doing with your data. You want to put it into useful information. All right, so that's basically the difference between these two ideas. Okay. Now, when you're coding, okay, because we're going to actually get into Java programming, and I actually want you to try programming, okay, is I am a huge fan of what's referred to as comments. Another way people say this is called inline documentation. It's called inline documentation because when you write code, it is encouraged to basically explain what your program is doing. For the most, you don't have to be super heavy with every little thing, but please comment your code. And what drives me nuts is a lot of these professional programmers that have been in the game for a while. They'll be like, I don't need to comment anything. I'm cool and smart. And da, da, da. It's really annoying because, like, sure, they might understand how their code works, like, right now. But I will bet money 6 months from now, if they have some complicated code and they go and look at it, they're going to be like, and they didn't have any comments, they're going to be like, what am I doing here? Why did I do this? They're going to spend so much time trying to, like, reread their program. So they're going to waste all this time trying to understand what they literally wrote, because code is not necessarily the most obvious thing to understand right away. Okay, it's not exactly like a novel where you just read a book and you're like, oh, yeah, that's all it is, or something like that. You actually have to, like, know the flow, and there can be larger things going on, and it's just a way. If you do this strategically, comments can save your efforts, like, greatly. All right. In this case, there's two different styles of when you put a comment. It's just free-form text. It doesn't actually impact your code. Again, it's a way to explain what your code is doing. You could also use it to kind of comment, like if you're working on a feature and it's just like you're trying to, like, build in some new capability, and you're just like, and you just need to, like, post a new version to the public or something like that. So it's like you could comment out code that's, like, partially finished, but it's like if you left it in that partially finished state, it would, like, break your program. So you could use, what I'm saying is, you could use comments to either explain how your program is working, or you can comment out, like, halfway done code that you want to work on later. Okay, so but in Java, there's two different ways of doing this. There's what's referred to as a single line comment, where it's literally just on a single line here. The way you start that, I'm just making it more visual. You start out with these two forward slashes, just slash slash. Okay, and then whatever you type here is blah 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 blah. That is just like whatever you want to put there. Another style of comments is referred to as a multi-line comment. Another way you might hear this is also called a block comment, because you have, like, a block of text, like kind of like almost like a rectangle thing. And the way that works, it's a little weird if you're not used to this, but you start out with a forward slash and then an asterisk, so like forward slash star. Type a bunch of stuff, blah 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 blah. They can have full paragraphs in here and all that kind of stuff, and then you end it in more of a reverse sense of that. We then end it with star slash. So to be clear, you start it with a slash, and then it goes to star here. But then the way you end a multi-line comment is you do with a star and then a slash. Okay. Now, one of the things, some other programmers, they get a little annoyed with me maybe, but, like, this is my personal convention. Other organizations have their own little, like, guidelines of what they prefer, blah, blah, blah. I tend to have a habit of, I actually use the single line comment to do basically multi-line comments. Now, it's not because I'm being bad about this process. I actually, when I'm reading a bunch of code, I don't want to be juggling back and forth between these two things, like distracting me. And I'll look at the comment if I need to. So for the most part, I'll use a single line comment for like even multi-line stuff. But I will use this multi-line stuff if I want to like separate sections of my code, and I just want to kind of have like a section heading thing, like comment form, like, oh, this is a whole nother thing. It's still part of the same file, but it's like a more visual aid, and I could put like /* and then maybe like a bunch of dash character, like looks like these minus symbol things, like a whole line of that. And then like, oh, section 2 or what, and then explain the summary of this. I'm going into another territory here. That's my style. Other people, you know, they get all whiny like, well, you have 2 lines of code, comment code, or comments here. You must use this multi-line thing. And I don't really care about that. It's more of a preference, really. So let's move on. Let me show you. Let's see here. Like, so for instance, here is, and we're going to do this. Okay, we're going to start this out. This is Java's starting point. So what I'm saying, look at this. I'm doing these comments here. I just put it in gray so you don't have to, it's like not that important, really. I'm just explaining it. When you become more used to Java programming, you don't have to like literally explain all aspects of your code. I'm just doing it in this slide form because you're watching this video. You're just getting accustomed to everything. And so that's kind of the deal with that. The situation here is when you have a Java program, I'll explain this. Like, it starts out, whatever you call your file, like say I'll go into this thing where we're going to create a hello world thing. If you saw my other video talking about installing NetBeans or an IDE, it's going to seem a little repetitive, but that's just because I don't assume you might have saw that other video, so I'm going to basically do that again here. And so with that being the case, you start out whatever you called your actual file, like say hello world.java. You got to say it the same way here, and you put it in this what's called a public class thing. We'll explain that later in other videos and such. The main thing is just like you just kind of start out your code like this. But the main point, actually, what I'm touching on, is I want to focus on this starting point thing, and I'm saying, like, look at this highlighted section. This is what Java has like mandated you must do somewhere, like your initial starting point of your program. I don't care if you have 1 million lines of code, like 200 different files or something like that. In one of those files, it must have this starting line of code, okay? And there's a lot of ideas in all of these called keywords. So I'm not going to explain the breakdown yet. Actually, what will happen is over time, if you keep with my lectures, this will start to come more into focus and understanding of like, oh, that's what they're doing, da 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 da. The main gist is you just have to type this, and you have to type it exactly like this, or else like the code will just not work. Okay, so you have to start out with public static void main, and we go into a parenthesis thing here, string with a capital S. It has to be a capital S here. All right, and then so string, and then right next to it is these square brackets. Then it says args, okay, and then we close it out with a parenthesis here, and then we open up this block of code with a left hand curly brace, which then you close it out with the right hand curly brace, and we're going to put code here. All right, so let's start this out. So here I am. I'm in NetBeans. Right, so you can use either, I'm using an IDE called NetBeans to write my code. You can see my other video on this if you want to use NetBeans. You can use other IDEs, even websites, to basically do this process stuff too. Check out my other video about like the orientation to Java programming to know what I'm talking about here. Anyways, I'm going to just start creating this. So what I'm going to do is I'm going to go to File, New Project, and I'm going to kind of skip through this because my other video I covered this a lot faster, but or a lot more in detail. So I'm going to just create this Java with Maven thing, and I'm going to use a standard Java application here. I'm going to just click Next. I'm gonna rename my project. Instead of Maven Project 1, I want to call it Hello World. Okay, in my convent, I'm gonna do it with a capital H and capital W. It's just kind of like the folder name, effectively, of the whole thing. And then this has already been changed. Yours might say something different at this group ID thing here. I did this for another thing before, so it remembered what I did here. What this convention is, it's like a reverse domain, like a web domain. That's kind of you put it in these packages. It's a way to make sure that your code won't interfere with other code that might be there. And so you do this, and so my website is junktext.com. So you do it reverse style, so it's like com.junktext. You can change the version if you want. I'm not going to do that. And then the overall package name of what I'm creating here is, which you'll see later, it'll say com.junktext.hello world, and it's all lowercase here. That's the convention of package names. So that's all I got to do. I'm going to click Finish. Stuff has happened over here. It's been created. NetBeans is doing stuff. I think it'll be done in a bit. In the meantime, so here's this kind of splash page on the Apache NetBeans, a start page thing. I'm just going to close this down. I don't really care about that. I'm not worried about this external change. I'm just going to keep moving on here. So in here, this is my new project, and we're going to create the code to do things. So don't worry about this. All these other folders you're dealing with. We're dealing with source code, so that's why we want to go with a source packages. I'm going to click the little plus sign here. That's where, again, see how this com.junktext.hello world things come up. Again, this is a package. Almost looks like a little package here. Now we're going to create what we did here on this slide. Okay, so I'm going to do a right click. I'm going to go to new. I'm going to create a new Java class. In this case, I'm going to call my class Hello World. Okay, the file name will be like capital H and a capital W, hello world.java. That's the convention when you're creating what's referred to as a class. It's like Java forces you to create these classes. You're going to understand later. It deals with object-oriented programming, but for the time being, think of a class as just like a file. Okay, so this is our file name that we're basically doing. In code, we won't have .java in code, but we need it to be the same kind of situation. You'll see what I'm talking about. So I'm then just going to click Finish. This stuff gets created. These are some auto comments. You can see now, looking at comments, these are block comments or multi-line comments, right? Because it's a /* and there's a bunch of text here. These are some default things. I'm just gonna kind of ignore this for now. So delete that. I'm gonna delete. This is my username on the system. I don't care about that right now. I'm going to. I think I did this in my other video before. I'm actually gonna make the font a little bit bigger, maybe even. I'm going to go to Tools, Options, Fonts and Colors. I'm going to make this a little bit bigger. Say 18 at least. Is that better? Maybe even a little bit more. Tools, Options. We'll bring that to 24. Font size here. That's a bit better. Okay. And then I'm going to move this back a little bit more. Okay, so this is our starting kind of code. This package thing, again, it's like how you group your code into something. It's like a box. Don't worry too much about this thing. It becomes important later when you get more used to Java programming. And so anyway, we're starting out our code, and NetBeans has already kind of created this stuff for me. It's like public class. It's like our file name. Hello World, spelled like this with capital H. capital W. It has to match my file name. But my file name says hello world.java. In this case, we don't actually put .java. All right. Now, what we need to do is this. This is what I'm talking about. We need to put this starting point. You just have to memorize this or write this down somewhere. It has to exactly be this. So that's what I'm going to do. I'm just going to start typing public static void main string with a capital S, string, these square bracket things, args, space over here, left hand curly brace. I'm going to press enter. NetBeans is going to create this right hand one automatically for me. And there we go. And then we can even put like / your code here, right? That's what I have on the slide. So it's basically the program doesn't do anything yet, but we have the starting point situated. Okay, now let's move on. Here we go. Now let's just create output. Like I was saying, let's just create some text to the screen. So one of the things is Java is a little wordy about how it does its syntax, and what they're doing here, and I'll explain these things later, just for now, when you're starting out. Just know that when you want to create program text to the screen, okay, in like a console or a terminal program, this is the capability that you want to use. And we started out with like system with a capital S, and then you have this like system.out.print, like you want to print it to the screen, okay? And then this is this print capability is you have this parenthesis thing, and then this is the text that you want to be shown to the screen. You have to put it within double quotes here, all right? And then whatever you want to type here, this is what's going to show up on the screen. That's what I'm saying. It outputs to the screen, hello world, okay? And you have to end your code that's not like a block of code, like, you know, with the curly brace thing. Anything's not a curly brace situation, it has to be with a semicolon. This is kind of like a period at the end of a sentence if you're writing a letter or something, you know, like, you know, you're typing out some one-page letter or something like that. So that's the convention with Java programming. So let's go ahead and just do this. I'm going to here, I'll just put an enter here, system.out.print, parenthesis thing here, hello world, like that. And NetBeans has already put the semicolon thing here for me. I think that this should work. I'll even change this. I know that this is on the bottom here. I was just doing that more flow of the effect. A lot of times you actually see the comments above your code. It's almost like title headings or something like that if you're writing a paper or something like that. But like, so I'm going to change this here. I'll say that it outputs hello world. Okay, now let's try it. So what I'm going to do is I'm going to save here and click the icon here, or you can press Control S basically, and then I'm going to go to run. Oh, this thing pops up the first time, which class we're dealing with. It's like, yes, this is the main class thing. I'm going to click that. It's going to do a bunch of whatnot stuff here. Eventually we're going to see right here, look at this little tiny font. Maybe I'll increase this. Let's see here, tools, options, is it, let me see, formatting, let me double check. There's, I don't know, font or something like that. I'm going to search for the font thing, because I forget. They got a lot of little settings everywhere. Ah, yeah, output window settings. I'm going to increase this. Where is my stuff? I don't know what it's doing. Here we go. I'll make that also 24. I'll click OK. I'll rerun the program and just click now this thing. I think, I don't know. We'll fix the font size thing later. Anyways, that's the thing here. It says hello world in this regard. That's kind of weird. Usually NetBeans lets me do that. Oh wait, this is the terminal. Maybe out. Ah, here we go. Output. Sorry. Yeah, there's lots of little areas. Okay, apply. Okay, now there we go. And now you can see the output better. And scroll down. Ignore this build success stuff. That's not part of what I typed. Right here is what we want to see. Okay, hello, comma, world, like that. That's what I typed up here. Okay, so this is, and to be clear, this is data. This is our data that we're providing, like, hey, this should be printed to the screen. And then the output, the information was just this, not system.out.print. We wanted only to see this text. All right. Now, let's keep going. There's also different ways to do this. Now, let's say we typed another line of code here where it says, like, my name is Bob. Now, my name is William, but in code, I'm going to just type it like this. All right. So let's see what, and this is the effect. I'm going to show you that actually all of this ends up on the same line of code, or same line of output. In the code, it looks like it's separated, but we're doing it without what's referred to as a new line characters, because we're using print. Now, let me show you. So here we are here. Okay. Scroll that down a little bit more. Here we go. System.out.print. What did I type? My name is Bob. Name is Bob. Put it like that. I can have a semicolon thing here. So, and it will say my name is Bob like this. Okay. I'm going to run my code. Give it a second. Doing some stuff. Let me scroll up a bit. And see, look at that. It's all on one line here. So it's like, what is this? Okay, that's because the print capability, you have to tell it when to put a new line character. All right, so I'm going to show you how to do that next. So here we are, moving forward here. This is with a new line characters. Now this is what I'm doing here. See highlighted here is this \n. It's like kind of built-in computer code in a sort of sense to tell where to put a new line character. What a new line character is like if you're typing something and you press your enter key and it goes to the next line. That's basically what you're doing in this kind of code form. All right, and they call it new line. Like it's not misspelled here. It's actually all together new line. Okay. Now, here we go. Let me see here. I'm going to go. Yeah, so all I'm going to do is add that \n. All right. So I'm going to do \n here. Now I'm going to rerun the program. It should change it to this. Hello world. On another line, my name is Bob. So now I can update my comment here that it actually does this. Okay. So yeah, you see how this kind of works now? I'll save this, Control S. I'm gonna show you more. Let's keep on going here. Another way you can have new lines is this other, instead of using print, you can use this thing where it's like print ln. That's not a 1, that's an L. So print ln, which is basically like print with a new line. Okay, it's not that print ln is better, it's that you can use it when you need to. It's just another capability. So I'm going to change the code around. Instead of doing this, okay, because sometimes the print capability is actually what you want. You can be more explicit of when you want a new line or not. And I'm changing it to be like in this fashion with the print ln. All right. I'm going to rerun the code. It's going to do its thing, and it's going to look the same. Okay, there's no change to what we just did. It's just now using a different way to write the code. So here we go. Right? Okay. Now, let's keep on going. So there's this print ln capability. I keep saying capability. There's another more formal way of saying this later. It's called a method. But to not overwhelm you with that, I just like to say capability. All right, so I'm going to keep on moving here. Now, let's get into variables. Okay. Now, variable, and I have a more. I'm going to break this down in kind of a little bit of briefing in a bit that you'll see. But to kind of have a more visual way of seeing this. In this slide summary, what you're trying to do a lot of times when you write code is you need to hold basically your little pieces like of data, okay? Like one little thing. So in this case, say we want to hold the number 2, and we want to use that later in our code. And the way we would do it is we create a variable to have that kind of built in. And the way the variable process works, the easiest way for me to explain it is a variable is basically a cup that, say we put stuff into the cup, and then from time to time we like look inside the cup to see the number 2. So in this regard, we have some num as the variable name, and we want to store the number 2. Okay. So that's the overall idea here. And the thing with a variable is things can vary later. Like we could make this later in time. We put 2 in there. It could be 3, or change it to a 1, or 8, or whatever, right? So that's kind of the idea of a variable. You have some cup thing that you throw data in, and you look at it and do stuff with it later. So in Java, there's actually a lot of different variable types. They like this concept, they call it primitive variable types. There are actually more. I'm showing you only 4 different ones, okay? There's actually more of these things, but for the most part, these are like the 4 main ones that you generally deal with in Java. And then from here and there, you might get into other things like char, which is like a single character, and other things. However, these are like the 4 main ones, okay? You have what's referred to as an integer variable, which are dealing with whole numbers, meaning like the number 2. It's not 2.3 or something. You can't have some fractional thing. You can only have a whole number and it's shorthand. So an integer means like a whole number. You say it as int. You can have negative numbers like -4 and such. There's nothing wrong with that. It's just, it can't be fractional. It can't be like whatever. So in this case, I'm just saying like int, we're going to call it this variable some num, like the label on it, and we're going to put the number 2 in there with a semicolon. This is what we did in Java code. We basically did this, okay? There's other variables. Say you do want to hold fractional numbers. Well, there's what they like to call is a double, all right? There's kind of this historical thing. It's like how much room, how accurate it is. Think of a double. The original one, it was actually called a float. Float is like, think of like a floating point number, like this decimal point can move around and stuff like that. So the original one was actually called float, okay, F-L-O-A-T. But later in time, they made it double with double precision. It means it can store a larger range of numbers. So that is why they call it a double. All right, now this is all lowercase here. And then say we have double another num is equal to 1.5 or something, right? So this is good for like holding currency, like monetary numbers or whatever, right? So if you want to have a decimal place situation, you want to use this double. This other thing, it's called a string. I have another visual aid later where it's like a string of characters, okay? Think of it like you put characters on like a necklace, letter by letter. That's why they call it a string, okay? Another way, basically, a string is just text. It can be anything, like A, B, C, D, E, F, 1, 2, 3, and spaces. A space is a character. These punctuation symbols, those are all characters. This little emote icon, smiley face thing, well, there's 3 characters here that make up that. In this case, I'm not including the double quote stuff. There's ways you can include double quote characters, but I'm not trying to confuse you right away. So all of this stuff in red, it's not that it's bad, it's just more to visually, you can see things different. All of this stuff in red is the text that we want to store in this string called some text. Now the one thing you definitely have to watch out for is do a capital S here. This is the only weird thing when you're dealing with text, like string. All of these others are lowercase, so including this Boolean. String has to be a capital S. You'll understand later why they do this, but just know that, okay? Otherwise your program crashes and dies and such. You don't want that. Now, a Boolean value is like true or false. I got a little joke built in here. Like, have you ever heard of Shakira? Like, she made this song that, anyways, where it's like, my hips don't lie kind of a thing. So I'm just saying, like, Boolean, it's like saying, like, do my hips lie? And it's like, no. It's like saying false. This is how you'd write that. Like, Boolean, my hips lie equals false. Okay.
All right, so now as you've been seeing in my slides dealing with variables, let me give you a classic example I love to do. I get, I've been mocked here and there by some of my students in the past. It's okay. This is now my more trademark kind of situation. All right, so how to explain a variable? You've seen in my slides that it's like, I'm trying to explain to you that a variable is like a cup. All right, so check this out. In the slides that I put there is, you have some variable called sum num. All right, I just made it kind of generic. You don't need to put like literally the word int to name your variable. So that's why I just make it kind of generic sounding. So anyways, with that, I have a cup here. All right, and I'm not necessarily trying to advertise Starbucks. It's just, I got the cup. Anyways, so I got this cup here. All right, and I want to put some stuff in it, right? You don't, it's great if you have a cup, but most people want to like drink some coffee out of it or something like that, right? Well, in this case, with what we're trying to do with our very simple Java program is basically so it can just hold a number. So the thing is, though, the variable, you want to have some way to reference this cup in code. So what you're basically doing, as I'm trying to identify, is you slap a label onto it and you want to identify it as something. So in this case, the label that we want to provide to it is called sum num. All right, so check it out, and bada boom! Check that out. We got, look at this very high-tech sticky note situation that just says sum num. All right, all right, you get the gist. So I have this sticky note label thing on this cup. All right, and in the slides, what I'm saying is we want to put the number 2 in there. All right, so in that case, check it out. I got some markers, like if I'm writing a whiteboard, these are very useful. And anyhow, so I want to put the number 2 here. So what I'm trying to do is I'm trying to represent the number 2 in a more visual sense. Okay. So with that in mind, I take my first marker right here and boom, we got a 1 in there. And then I got another marker here. Boom. Let's see if you can see that. Okay. We got red and green marker in here. Okay. Anyways, I have 2 markers. Let's see, you put it like that. All right. So I have 2 markers in this cup. So what this is saying is, that's what I did in code. Like if I say that, int of sum num equals 2, well, this is basically what I did in a practical sense in the code, all right? But then it's a variable, right? It can vary. So with that in mind, we could put, oh my goodness, check this out. I got another marker. We could put another marker in here and have, now here's if you can see that, that's a black marker in there. Anyways, don't worry about the colors of the markers. There's 3 markers, okay? So now this variable, sum num, contains a value of 3, okay? Because it can vary. Again, we can make it vary again. Check this out. And say we want to only have it hold the number 1. Well, we just take out 2 of these markers, and there's only 1 marker in this cup now. So that's, in essence, all you're doing in code. And that's why you want to have a variable, because it's a great, you'll hear this kind of formality, it's called a data structure. It's a very good data structure to hold something that you want to use later on in code. You want to be able to put something somewhere so then later on when you need it, you can pull it out and, oh, the user ID was 1, or maybe it's 2 or 3, right? But you want to be able to somehow do that. You want to hold that value somewhere, okay? So that's basically the gist. And the only thing is with Java, it's very kind of particular about what you put in this cup. So in this case, I'm just representing that each marker, okay, is like a whole number. Okay, so in this case, in this regard, since we're dealing with an integer variable, that it does not want to hold any fractional things. Like I can't put half a marker in here. It's gonna be like, no, you cannot put a half a marker in this thing. Java is just very intense about the kind of variable types it has. So it doesn't like to mix and match like other languages are a little more loosey-goosey. So with that in mind, say if we wanted to store some text, all right, you saw on the slide there, that some text, and there's like, starts out with like A, B, C, D, E, F, 1, 2, 3, and so forth. Well, unfortunately, I can't put text in this cup because Java will only let me hold whole numbers or integer values. Okay, so I can have like 3 markers or whatever, but I can't start throwing text in here now. Now, if that's the case, if we want to have some sort of a variable to hold text values, well, same process. Check it out. I got another cup here. It just says some text. I threw a little sticky note on there. All right. Now, the values that I showed on the slide is this. We want to have this text here. So it's like A, B, C, D, E, F, 1, 2, 3, and there's some there's spaces in there, there's punctuation symbols, there's anything you want to put in here. It doesn't really matter. It's just a bunch of text, okay? Blah, 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 blah. Some words, letters, so on and so forth. And we want to, boom, put it in the cup. That's it. That's effectively all that we're doing in this case. In this regard, this is referred to as a string variable. One of the things you definitely have to watch out, though, with Java is you use a capital S to identify that that's a string. Later on, you're going to realize why Java has this kind of weird in this kind of area, because you might be already wondering, like, whoa, wait a minute. You're talking about, we have integer, and that starts with the int, spelled all lowercase, and then we have double, right? Where it's like, it's all lowercase. Then we have string, okay? And that one starts with a capital S. Later in time, you'll understand the subtleties of why you need to do this. The main thing is just when you're identifying the variable type in this regard to hold a string value, it's just like text on here, and we would just want to put it in here or refer to it like, oh, what's in here, kind of a thing. That's the whole point of the variable, okay? But yeah, just, a newbie mistake is a lot of you, if you don't put a capital S, the program crashes and you're like, what's going on? But that's a gist, kind of get you in the right direction. Also, the thing is, definitely don't, when you're putting, when you refer to my slides again, that when you have the text values in Java, you definitely have to have double quotes. Don't do single quotes, okay? Especially if you're familiar with other languages. They are way more forgiving, but in Java's case, it's like, no, you use double quotes for string values, okay? Yeah. All right, so let's continue on with more of my slides and so forth. I want you to start like actually doing coding and stuff, all right? Okay, here we go.
Now, as you saw in all of the videos, or the video that I just went over, I gave you more of a breakdown of how that visually works with the cup and so forth. Different cups you might have. Now, what I was explaining is like talking about the string variable. This is basically how you should think about it. Is you're actually just having character by character, you're building up your text, okay? Whatever you want to type in there. In this case, this is a little necklace that I created, and it just says I heart tech, okay? And you can actually literally write the heart symbol. This is actually Unicode. It's not like some graphic thing. Unicode, if you're not familiar, it's like it is text, but you can they actually have little symbols and stuff like that too. It's not just like letters and numbers and stuff. So you could actually represent this in Java code. So you could have this like I heart tech, okay? And that's basically the visual idea of what a string is. It's a string of characters, okay? So that's the general gist of how this works. All right, now let's keep going. There's ways that you can combine text, like you combine different strings together. Another fancy way to say this is you are concatenating, okay? So the concatenation operator is this plus symbol. You're not doing math, you're actually basically kind of gluing two strings together, two things of text. So that's, or you're combining it together. So to concatenate something is the same thing as like combining two text strings together, okay? Now, for those of you that might be familiar with, say, Linux or Unix and stuff like that, there's actually a command in the environment called cat, and what that's about is that's if you want to read text files and whatnot in the terminal, you type cat and then whatever the text file is. So my little way of remembering this cat thing is cats play with strings, like a physical cat, like they like playing with strings. So that's another way that you can think about this relationship between concatenate and strings and such. All right, so let me show you an example in Java of how this works. That, say if we do this, say if we do system.out.println, and it's like cough, right, C-O-F-F, and then do plus concatenate with cough E. Now I don't even, and then what I'm saying is we don't even have a space character. If we run this code, this is what's going to happen. Let's do it. So I'm going to come over here. I'm going to just press enter a couple times. So I'm just going to do system.out.println C-O-F-F. I want it to have to say coffee. I'm just doing it this kind of weird way. Show you the idea of this concatenation thing. Cough E. Okay. So I will run this code now. Give it a second. It's doing its magic. I'm going to scroll up because I got all this build static stuff. Look at that. It says coffee. Even though it looks like they're separated in code, they are separated, but I glued them back together using this concatenation operator. Okay, so that's the effect of what's going on. And I didn't have any space. I didn't put a space here or something like that. That's why these are not like spaced out differently. Okay, it's just put together as I typed it. So it says coffee all together. All right. So that's the idea of this concatenation operator. But another useful thing that you need to do a lot is, like, say you have a variable like int of favorite num is equal to 2. Well, right, you have this integer variable and we use that print line thing. We can concatenate variables. Now, I know that this is not a string, but what this print line capability is doing is what it's internally doing behind the scenes. It's actually temporarily like converting that to a string and then allowing it to be glued together, combined together in this way. So if I put like favorite number, right? So this is just text in red, and I end it with these. I have these double quotes plus like concatenate. We're not doing math here. We're gluing the two strings together. And in this case, it will convert it to be, and this is going to represent the number 2, because at the time, in this is when we're looking inside the cup. Like, what is inside the favorite num variable? Well, there's the number 2. We haven't changed it yet. So that's why it says the output will be favorite number is 2. So let's try that out. So I'm just enter. I'm just get some more white space in between everything. Let's do that. Int of fav num equals 2. Another line here. I'm going to then say system.out.println. I'm going to start it with favorite number. Now I have a space here, okay? So you see where that pops up. Then I'm putting the concatenation thing here. I'm putting a little space characters in between here. It just makes it more readable. And then fav num. All right. So here we are there. Now I'm just going to save it, run the code. Should work. Give it a moment. Here we go. Yeah. So now it says favorite number and it says 2. All right. So behind the scenes, we didn't see anything of this fav num and all that. We don't even know about that. We just see the output is here. So the input that I provided was this text string, and the other input was the integer variable called fabenum. The output together combined, since we concatenated this, put it all together, and this is what we see as favorite num is 2. Okay, now I'm going to keep going. Oh, so we're almost done with the lecture. One of the things I want to just let you to understand, another thing, like I touched on data versus information. There's this other concept that you want to know, that there's actually a difference between what's referred to as an algorithm versus a computer program. Okay. So the basic thing with that regard is I'm kind of summarizing that an algorithm is like human speak, or like human logic. This is how we basically think. Whereas a program is like how the computer actually does this. Okay. Now, look, the main difference between the two, there's actually not that big of a difference. If you see right here, I'm saying an algorithm. These are your step-by-step instructions. Also, a program is also step-by-step instructions. The thing, though, is an algorithm, you should think of it more like it could be expressed as what's referred to as pseudocode. It's like fake code, okay? There's no standard to pseudocode, okay? Just so you understand. You might be taught by other people, professors, books. There is no standard to pseudocode. It's how you want to like summarize how the program, the flow, should work. So in this case, if you look at this kind of grayed out section here, this is actually pseudocode. It's fake code. I know it looks like English. That's fine. It can be in English. We could also put this in comments, like in actual source code too. So in this case, say I just demonstrated, say the whole point of the program that we want to build is like, well, the first thing is I want to set my favorite number to 2, the number 2. Then, after doing that, well, output that number to the screen. That's it, right? That's all we want to do in the code. That's the flow. This is our algorithm. This is our step-by-step instructions expressed in more human speak in that sort of sense. The program, this is actually like you actually put your code in Java, right? So this is actually Java syntax at that stage. And when you do that, that's referred to as source code, okay? So I have, like what you just saw before was int fabenum is equal to 2. And then we're going to print it out. That is actually putting it in code form. Now, the thing with an algorithm is this is the general gist of what we want to do. Well, we could do this same thing in another programming language, like I touched on PHP or JavaScript or C or Delphi if you want, right? You can do that as well. You would just write the syntax differently in that other computer speak, whatever language you're trying to write it in. You would then implement the algorithm into how the code should look in that language. Now this is how Java, you would write it in Java. All right, does that make sense? And the last thing I want to touch on is, you don't see this quite as much, unfortunately, but it's everywhere. This is how modern computer programs work, okay? There's a thing, like we're going to get eventually into like object-oriented programming and all this other kind of stuff. Nonetheless, every single computer program since like the 1970s and so forth onward, in modern programs, I don't care if you're object-oriented programming, whatever, model view controller, things like that, they have a bunch of ways to organize code. It doesn't really matter. Like, the way the whole flow of how code works, if you can understand these 3 aspects, like, you are going to be an excellent programmer. It sounds simple, but these are literally your 3. You have 3 main control structures. You have 3 main, basically, building blocks of how you would write your code. All the other object-oriented stuff or whatever, methods and classes and all this other kind of stuff, that's how you kind of refer to other things. But the flow of how the logic works does it in these 3 fashions. Now, what I showed you practically is, it's called sequence, where you're just writing your code in sequence. Like, step 1, do this. Step 2, all right, now do this. Step 3, and then have this happen. All right. So in a practical sense, I'm going to press my back button. This is sequence. Well, step 1 is like here. So the algorithm is doing the same thing here. Step 1 is, well, set my favorite number to 2. Then step 2, our next step is then output that to the screen. That's our sequence that we want to happen. All right. So this is called like sequential programming. We're just doing it in order, one line at a time. Later on, not in this lecture, we're going to go into what's referred to as selection or conditional programming, where it's like, if this occurs, then do this, else, then do this. I'm not going to explain the ins and outs right now, but that's like the idea. You're making a decision, basically. Another way of saying that is you're making a selection of which block of code you want to enter. Another thing is called repetition, where you're doing loops. And there's different types of loops out there. Here's a while loop, and I'm not even explaining what X or Y is above this. Same thing here. I'm just saying this is the idea of repetition. Okay. The main thing is you have 3 main control structures: sequence, selection, and repetition. Okay. And I'll stop there. Okay, so that should hopefully get you on the right track, and hopefully you've been following along with actually trying to write this Java code. Okay. So yes, I hope you have a good day. All right, thank you for watching.